Hello friends, welcome to Risingpearl.com. Today we are talking about series 8 where we are learning a great deal on arithmetic progressions. Friends, this is webisode number 9 and today we are going to continue to find out how to solve questions where we may need to find the nth term of an arithmetic progression. This is part 6. So in the last 5 webisodes, they were part 1 through part 5, we have been looking at all kinds of questions that we may see on the series arithmetic progressions, and we started off with some simpler type of questions, and over the course of time we have moved on to more challenging, more difficult kinds of questions. So in this webisode we are going to continue to look at some more different types of questions that you may see in your tests and exams. So question number 21, and as you know by now, this is a running count of all the questions that we have handled in the series. So how many three-digit numbers are divisible by 3? So this is a very strange question in that it does not say this is arithmetic progression question. So how will we know this is an arithmetic progression question? Honestly, I do not have a good answer for that. But what we will do is we are going to take a step-by-step approach and figure out what the question is telling us and see where we go from there. So how many three-digit numbers? So let's write three-digit numbers. So the greatest two-digit number is 99. This is the highest two-digit number. Then we get three-digit number 100. Then we get 101, 102, and then this goes on and on and on. And then eventually we get 999. And this is the largest three-digit number. And then we have four-digit number. So we know this, right? So the question is how many three-digit numbers? So we are talking about three-digit numbers. That is, this is what we are talking about. So whatever the answer is, it basically relates to these numbers. So 101, 100, 101, so on and so forth. Now, how many of these numbers are actually divisible by 3? So what we are going to do, friends, is that we are going to take the smallest number or the first number in our set, which is 100, and we will divide this by 3. So let's do 100 and we divide this by 3. So 3 3s are 9, 1, 0, 3 3s are 9. Right? And then, so we have to get 0.3. So in other words, when we divide 100 by 3, we don't get a whole number. We get the quotient is actually it's a decimal number. That means 100 is not divisible by 3. But what it also tells us is that 33.3 is what we get. So if we do 34, for example, if we take the next whole number immediately greater than 33.3, which is 34, and if we multiply this by 3, then what do we get? So 4 3s are 12, 1, 3 1s are 3 plus 1, 10. So what it tells us is when we try to divide 100 by 3, we got 33.3. So that means 100 is not divisible by 3. But the quotient is 33.3. So the immediate next whole number, which is greater than 33.3, is 34. So if we take 34 and we multiply this by 3, we get 102. It means 102 is the first three-digit number which is divisible by 3. And I want you to make sure that you follow this point. If you are not following this point, please pause the video and rewind and play back and see exactly what we are doing. So very quickly again, so we took the smallest three-digit number, we divided that by 3 because the question is divisible by 3. So we divide 100 by 3 and we get 33.3, which tells us 100 is not divisible by 3. But because we are trying to find out the immediate next number which is divisible by 3, and quotient is 33.3. So we try to find out which is the immediate whole number greater than 33.3. Obviously that is 34. So we multiply 34 times 3, we get 102. That means 102 is the smallest 3-digit number which is divisible by 3. The other point is, now how do we find out the next number? Right? So in other words, let's do this, and this will help you see through this. So for example, if we take 5, then we have 10, then we have 15, we have 20, and let's say we have 25. So if we have this arithmetic progression, we know that all these values are basically divisible by 5, right? So 5 ones are 5, right? So now 5 2s are 10, 5 3s are 15, like it goes on like this. But after we find out 5, how do we get the next term? How do we get 10? We simply add plus 5 and then we get the next term. So similarly, once we know 10, how do we get 15? We again add plus 5. That means, and this is something that we know from our experience over the years, right, is that since if we keep increasing these numbers by 5, if the first one is a multiple, if the first one is divisible by 5, and if we keep adding 5, 5, 5, then each of these numbers will be divisible by 5. So similarly, for us to find out the next number, we simply have to add plus 3 to it, right? So that will be 35 times 5. So that will be 105, right? And we will keep going on like this. Now, what will be the last term? So let's do one thing. Let's give ourselves a little bit more space. Well, before that, let's try to find out what is the last term. So in other words, so we found out which is the smallest 3-digit number which is divisible by 3. So what about the largest 3-digit number? So what we are going to do is, we are going to look at this number which is the 4-digit number, the smallest 4-digit number. We will try to divide this by 3, right? So if we do that, again we will basically see that will be, so if we divide 1000 by 3, so we will get 391033.3. So we will get 333.3, and this is the smallest 4-digit number. So in order for us to find out the largest 3-digit number which is divisible by 3, what we do, we take the numerical part before the decimal and multiply this by 3, right? Because when we divide 1000 by 3, we realize the quotient is 333.3. So which is not divisible, right? Now we are trying to find out the immediate next term. So this number is not divisible by 3, but we are trying to find out such a number which is right next to this, closest, greatest number which is right next to 1000, which is divisible by 3. So then we take the numerical part without the decimal and we multiply that by 3. So 333 times 3, if we do it, this will be 999. So this is going to be the last term. So let's see, initially our set of numbers, these were all the 3-digit numbers. But then we found out if we are talking about the numbers which are divisible by 3, then that is a very different set. So now let's clean this up a little bit, give ourselves more space. So now what has happened is our set of numbers really look like 102, 105, 108. So we are continuously adding 3. Then we are adding 3. And this goes on, right, till we get 999. So friends, now this actually is arithmetic progression series, right? This is an AP. Because we have first term and each subsequent term is basically, we add 3 to the first term to get the second term. Then if we look at second term and I add 3 to it, we get the third term. That means this is nothing but a arithmetic progression with first term as 102 and common difference as 3. And what we have to find out is how many 3-digit numbers are there. That means we have been given an arithmetic progression and we need to find out how many such terms are there. So like this is the first term, this is the second term, this is the third term. So how many such terms are there? So what we are going to say is we are going to assume, let's assume there are n number of terms. There are n number of terms. We'll assume that, right? Total n number of terms. So the nth term will be given by the formula a plus 1 minus n times d. Or in other words, now nth term, which is the last term, which will be this 999. So 999 is equal to a is 102, that is the first term, plus n minus 1 times d, which is 3. So here we can actually actually divide both the sides by 3. So then this side will be 3, 3, 3, and this one will be 34, plus the 3 will cancel off, so we will have 1. So 1 times n minus 1 will be plus n minus 1. And let's do it here. So what we will have on this side, so we will have 3, 3, 3 equal to 34 minus 1 is 33 plus n, or simply we can say n is equal to, so if we take this on the other side, it will be 333 minus 33, so which will be 300, right? So 333 minus 33 will be 300. So n is equal to 300. So what does it mean? It means there are 300 numbers which are 3-digit and which are divisible by 3. So friends, as you can see, this is a really powerful tool. The arithmetic progression and this aspect of finding the nth term using this formula an equals a plus n minus 1 times d, you can see how powerful it is, because we could, using arithmetic progression and this formula in particular, we could find out how many 3-digit numbers are there which are divisible by 3. So let's take a look at one more example, and I wanted to take some time to walk you through these types of questions so you understand that these types of questions, these categories of questions, these flavors of questions are also, on the surface they may not look like arithmetic progression questions, but very easily, if you take one step forward, if you can simplify them the first level, then it will become a very straightforward arithmetic progression questions. How many 4-digit numbers are divisible by 7? So it's very similar to question as the last one, right? So what is the greatest 3-digit number? Clearly that is 999, right? And then we start writing the 4-digit number. 1000, 1001, 1002, and we write like this till we get to 9999, and then we get 1 and 5 zeros, which is 10,000. So we are talking about how many 4-digit numbers. Our initial set, we are going to focus on this, which is from 1000 through 9999. So we are going to do exactly what we did the last time. So first we are going to basically divide this by 7, right? So let's do this. So we have 1000. Let's divide this by 7. 7 ones are 7, so 3 0. So 7 fours are 28. So 2 0, and 7 threes are 21, but this will be 7 times 7 twos are 14, and 1, so it will be point something. It will be point something, right? So in other words, 1000 is not divisible by 7. So if we have to find out the immediate term next to 1000 which is divisible by 7, we have to take out 142 and multiply this by 7. So 142, let's multiply this by 7. And this step I mentioned, it's very, very, very important for you to understand this step. We talked about this in the last example too, right? So if you multiply this, so 2 sevens are 14, 1, 7 4, 28, 29, 2 carry over, 7 ones are 7, 8, 9. Actually, we made a mistake. Yes, we did. If 1000 is not divisible by 7, then we have to, instead of taking 142, we have to take 143. Right? Because if we take 142, that means we are trying to find out the number which is immediately smaller than 1000, which is divisible by 7. But by taking 143 times 7, we are finding out the immediate next higher number which is divisible by 7. So see, we almost made the same mistake that I am actually advising all of you to avoid, right? So that is why this does not make sense. So in other words, we have to take 143 and multiply that by 7, because 142 point something is for 1000 and that is not divisible. So we have to get the next number. We have to go to 143 times 7. So 7 threes are 21, 2 carry over, 7 fours are 28, 30, 3, 7 ones are 7, plus 3 is 1001. So looks like 1001 is the smallest 4-digit number which is divisible by 7, right? So now what is the largest 4-digit number which is divisible by 7? So if we divide, so it's 10,000, right, by 7. So it will be exactly very similar to this, right? So 7 ones are 7, 3, 0, so 4, 28, right? So 28, 20, so 7 twos are 14, 14. So we have 6, 0, and now this last digit will be 7 8s are 56. 56, right? So we will have 56. And then it will be a point and we will get something. So 10,000 is not divisible by 7. But if I am trying to find out the immediate number smaller than 10,000 which is divisible by 7, that number will be 1428 times 7, right? Just the same way, in this case, when I divided 1000 by 7 and my quotient was 142 point something, because I am trying to find out the next larger number, immediate larger number which is divisible by 7, I basically added 1 to 142, right? So we got 143 that way. Now in this case, when I'm dividing 10,000 by 7, I'm getting 1428 point something. But if I want to find out the largest number which is smaller than 10,000 divisible by 7, that number has to be 1428 times 7, because 1000 itself is 1428 point something. So if I just take the point part out, if I just multiply 1428 times 7, that will give me the largest 4-digit number which is going to be divisible by 7. So if we do this, so we will get 1428. So 56, 5, 14, 9, 1, 28, 29, 2, 9, 9, 9, 6. So friends, what we have, we start out with 1001. Now let's clean this up and give ourselves a little bit more space. So we start with 1001 and then 1008. How did I get this? I just simply added 7 to this. So if this is 1001 plus 7 is 1008, so the next number will be 1015. So we go like this all the way up to 9996. So then now we see this is the arithmetic progression whose first term A is equal to 1001, 1001, and common difference D is 7. So the question becomes, how many 4-digit numbers are divisible by 7? So how many? So if we assume, let's say there are n numbers or n terms which are in this series, then the nth term or the last term, this one, we can write that as an equals a plus n minus 1 times d, or a will be 1001 plus n minus 1 times 7, which will be equal to 9996. 9996. So if we just solve this again, we can divide both sides by 7. So if we divide this, so we will get 143 plus 7 will go away, it will be n minus 1, and this one will be 1428. And if we simply just solve this over here, so n will be equal to, so here it will be 143 minus 1, 142, and when we bring it on the other side it will be negative. So we will have 1428, which is this, minus 142. Let's just do it here, minus 142. So if we actually do the subtraction here, 8 minus 2 is 6. So here is 2, so 1 carry over 12, 12 minus 4 will be 8, and so 3, so 4, 1 went away, so we have 3, 3 minus 1 is 2, and this one comes down. So we have 1286. 1286 4-digit numbers that are divisible by 7. So I want you to just pause the video and understand what exactly are we solving here, the magnitude of what we are solving here. Because simply by applying arithmetic progression, we are able to just say that there are 1286 4-digit numbers that are divisible by 7. So you can imagine how far-reaching the applications of arithmetic progressions are, right? Let's take a look at some more questions. How many multiples of 4 lie between this and this? So this is very similar question like the last two questions, but asked in a different way. So what do I mean by that? So what is a multiple? So what is a multiple of 4? So we know 4 is a multiple, right? 4 times 2, 8 is a multiple of 4. 12 is a multiple of 4. 16 is a multiple of 4. 20 is a multiple of 4. Right? Multiples of 4 simply mean that we are basically multiplying 4 times 1, we are multiplying 4 times 2, we are multiplying 4 times 3, right? And whatever we get, they are the multiples, right? So 4 times 1 is 4, then we have 8, then we have 12, and it goes so on and so forth. These are all multiples of 4. But the question is how many, and again how many, meaning we are looking at the count, how many multiples lie between 10 and 350. So this is interesting. So because it is between 10 and 350, so we will ignore this. So we will start with 12. So in other words, we start with 12 and we add 4 to it, then that next one will be 16. Add 4, it will be 20. So this is going to go on like this. Now we need to find out the last term. How do we find out the last term? So we do what we have been doing. So we will divide 350 by 4. So let's do it here. So 350 divided by 4. So 4 8s are 32 minus 1. So there will be 3 0. 4 7s are 28. So 2 and we decimal 20.5. So that means we are trying to find out the last multiple which is smaller than 350. In between, meaning 10 and 350 are not included. So when we divided 350 by 4, we are seeing that 350 does not fully divide by 4. So it is a decimal. Now, which will be the immediate smallest number from 350 which will be divisible by 4? That will be, to find that, we have to get 87 times 4. And this is what I have been saying is very important for you to understand. 87 point. So because when we divided 350 by 4, the answer is 87 plus 0.5. Right? So 350 is greater than 87 times 4. Right? So in order for us to find out the immediate number smaller than 350, which is yet a multiple of 4, we will multiply 87 times 4 to find that out. So if we do that, this will be 28, 2, 32, 34. So clearly this number is 348. If we were to find out immediate multiple of 4 which is greater than 350, instead of taking 87, we would have taken 88. If we had to find out the immediate multiple of 4 which is greater than 350, so we would have taken 88 and multiply that by 4, and whatever is the answer would have been the answer. But we are trying to find out the immediate smallest number, smaller than 350, which is multiple of 4. So we will take 87 and multiply that by 4, right? Because 350 is 87.5. It's 87 point something. So now, friends, this is again, this is a arithmetic progression question where we have our first term 12, common difference. So we have a equal to 12, common difference is equal to 4, and our last term is 348. So if we say there are n number of terms, so how many? So let's say there are n number of terms. So we say an is equal to, let's write the value here, 12 plus n minus 1 times 4 is equal to 348, because an gives us the nth term. If we say there are total n terms, so the nth term is given by this formula, but the last term actually is given as 348. So from here we can simply divide both sides by 4. So this will be 3. So 4 3s are 12. So 3 plus this will be n minus 1, and this one will be 87. Or we can say this will be equal to, so from here n is equal to, so this will be 3 minus 1 is 2, and the 2 will go on the other side, it will become negative. So it will be 87 minus 2, 85. So what is 85 actually? N is equal to 85. What does it mean? It means there are 85 multiples of 4 in between 10 and 350. So if you ask me, this is really fascinating. as to what type of questions we are answering. And we would never have thought these are arithmetic progression questions, but indeed, using arithmetic progression, we are able to solve these types of questions. So let's see if you want to do one more question. Maybe I am going to be able to give you the guideline and you can solve it by by yourself. I know the video is becoming really long. Find the 20th term from the last term of the AP. Well, this is a very interesting question. We have to find out the 20th term from the last term of an AP. So the arithmetic progression is given. We have a full arithmetic progression. The first term, we can find out the common difference simply by by subtracting 3 from 8. So 8 minus 3. So let's see what is given actually. So A, which is the first term, is given as 3. Common difference is going to be simply these two are known, so we will do A2 minus A1, or 8 minus 3, which is 5. We could have also done 13 minus 8, same thing. So we know A and we know D, right? So A is this 3 and D is 5. So what is that we have to find out? The 20th term. So now let's write it this way. So we have A1, A2, A3, A4, and it goes like this, right? It goes like this. So now this is how we write the arithmetic progression. So it looks like obviously there is a last term. Let's just say that's last, AL. So what the question is saying is that we have to find out the 20th term from this side. So whatever the last term is, we have to find out the 20th term going this way. So let's do one thing. Let's make it a little simple. Let's say we have, 5 terms, right? Any arithmetic. So let's say we have 5 terms. So A1, A2, A3, A4, and A5. So we have 5 terms in any arithmetic progression. And the question is we have to find out the second term from last. So let's understand what does it mean actually. So we have to find out the second term from last. So if there are total 5 terms, so then this will be last and this will be second from last. So we have to find out this term, right? So in other words, so if we have to come from this way, because this says second from the last, so we start here and we come here. This is the second term, right, from the last, which is what term from our regular convention? It is a 4th term. So how do we find out what term this is? So one way to think about this is the last term, if it is 5, second from the last, so the last is 5 minus second, this gives us 3. But the term we are looking for is 4, so we have to add plus 1 to it. If you are not following this, friends, I want you to pause the video and understand what we just talked about. We want to find out second term from last. So we have total 5 terms. So this is the last A5 and this is second from the last A4, right? So how do I know if it is the 4th term or the 3rd term? So to find out 4, we can say the last term is 5, so we took the 5, this is the last term, right? And we subtract 2, which is second from last, so we subtract 2. But if we do just 5 minus 2, we get to the 3rd term. But in reality, it's the 4th term, so we have to add plus 1 to it. In other words, what we are trying to get at is here, the way we are going to solve this question is we are going to find out total number of terms. So let's say there are 50 terms. Let us just say that there are 50 terms total, right? In other words, A50, let us just assume A50 is 253. Then the term, 20th term will be, it will be 50 minus 20 plus 1. In other words, this will be, so 50 minus 20 is 30 plus 1, 31. That means that A31 is the term that we are actually looking to find out the value of. So this is very important for you to understand, friends, because normally whenever we use A1, A2, A3, it's always we start from the beginning. We don't start from the end. But if we start from the end, and if it is given that second term or third term, you make sure that you put the last term and you subtract, the value whichever term from last, and don't forget to add plus 1 to it. Because in this example, 5 minus 2 will give you 3, whereas the actual term we are looking for is 4. So we have to take the last term minus however many terms from last, we subtract that and we add plus 1 to it, right? So now I'm not going to actually solve this. You can find out how many terms in this series. If the series starts with 3 and the common difference is 5 and the last term is 2, 5, 3, in the last few questions we have been solving this and finding out how many terms. So you will get a number. So like if the number is some number like 50 or any other number, so what we do is we simply then find out the 20th term will be that number minus 20 plus 1. And whatever that value is, so like in this case if it is 31, you are looking to find that term, that 20th term, or in this case you are looking to find that 31st term. So you have to find out the value of the term. So you have to do this like, so a plus n minus 1, n is 31 minus 1 times d. You have to put the values for a and d and find out what is the value of this term. So friends, let's see if we can take one more example. I know this is becoming super long video for us. The sum, okay, we have not talked about the sums yet. So I think let's pause. Let's conclude this webisode right here. And maybe in the next webisode, we will start to take a look at sum of arithmetic progression.